Hi guys, Steven here, and welcome to the second lecture of this MATLAB crash course series that I have planned. So in this lecture, we're going to talk about relational and logical operators. So a few of the topics we're going to talk about today. First, we're going to talk about a review of Boolean variables, and we're going to look at relational operators. We're going to look at logical operators, the precedence of operators, and then we're going to kind of finish it off by talking about short-circuiting with logical operators. So first we're going to talk about a review of Boolean variables. Now, Boolean variables are something I touched on a little bit in the last lecture video. If you don't remember me talking about that, I would suggest going back. I'll have the link in this video. And I would go over the part where I talk about Boolean variables. But I'll give a quick recap. So Boolean variables can be of two types. They can either be logical true or logical false. A logical true is represented by a 1. A logical false is represented by a 0. Now, if you remember correctly, these Boolean variables can be derived from a simple variable expression, as I talked about in the previous video, or they can be derived from relational operators, which I'll talk about in a second. But so if you remember what I talked about in the last video a little bit, you could write a simple expression in MATLAB to get a Boolean variable. I could say var equals true, and then I'm going to get a logical true variable. It'll be a logical 1. I could say var equals false, and I would get a logical 0. I could say var equals Boolean 1, and since you remember a 1 means true, it will automatically create a logical variable, a logical 1. And so that's a little bit what I talked about in the last video. These are all the logical variables. One question they might be asking me is, what are the purpose of these Boolean variables? Why are these important? Why do we have to learn these? Boolean variables are a topic that becomes really important once you start working with conditional statements. I'm not going to talk about too much of what conditional statements are. That's going to be for a discussion in the future. That'll be something I talk about in another video in the future. But for right now, you need to know that you need a strong background in Boolean variables because they become really helpful once you start working with conditional statements. So like I said earlier, you can also get a Boolean variable by using a relational operator. It's going to be the next thing I talk about. So a relational operator is a common mathematical expression that can yield a Boolean true or false when used with two values. Now this might sound a little daunting, but it's a fairly straightforward idea. If you remember in your math classes back when you if you took in like middle school or elementary school, there were certain operators that we used then, and these operators kind of come back in MATLAB. So some of these operators include the less than sign and the greater than sign. If you remember when you're comparing two numbers, like 4 is greater than 3, that's using one of these operators. You can use the less than or equal to sign. This looks a little bit different than you might remember in mathematics. In MATLAB, to type less than or equal, you type the less than sign and then type an equal sign. Greater than or equal to, you type the greater than sign and then the equal to sign. Equality, so like saying two numbers are equal to each other. So like saying 3 is equal to 3. In that case, we use two equal signs. We don't just use one equal sign like you would in a common math class, because if you remember, we were talking about here, you use a single equal sign when you're assigning a variable. So we can't use one equal sign to show equality. You use two equal signs to show that two numbers are equal to each other. And finally, inequality, or showing that two numbers are not equal to each other. To type this, it's going to be a tilde and an equal sign. To find the tilde, look in your keyboard. It should be in the top left corner by the 1 key. If you click Shift and then click up there, you should get a tilde, which is this little symbol right here. That's going to represent inequality. And so what essentially happens in MATLAB is if you type a relation using two numbers and using one of these operators, if the relation expressed is true, then the expression will yield a logical true. If the relation expressed is false, then the expression will yield a logical false. It's very intuitive if you look at it. The best way to kind of go about it is by looking at some examples here. So let's look at these right here. I use all sorts of different operators here. So the first one we have here is 4 is greater than 2. So this expression makes sense. 4 is in fact greater than 2. That means if you were to type that in the command window on MATLAB, so 4 is greater than 2, you'll see that the result is a logical 1, or logical true. We ended up with a logical variable, but we didn't assign anything. We didn't say var is equal to true. We wrote an expression, and we got an answer. So I could even make it an expression. I could say var is equal to 4 is greater than 2. So whatever the result of 4 is greater than 2 is, that's what var will be equal to. And if you look here, we do in fact get a logical 1. So there's an example of 1. Here's another one. 3 is less than or equal to 1. This expression does not make sense because 3 is not in fact less than or equal to 1. We can prove it if we look here. 3 is less than equal to 1. We get a logical false because the expression is not true. 9 is greater than or equal to 9. So this is going to be true because we have the equal sign here. Is it greater than or equal to 9? Well, 9 is equal to 9, so it meets the requirement. So if I were to type 9 is greater than or equal to 9, we end up with a logical true. The next one, 3 is less than 3. So this one might be a little tricky, but 3 is in fact not less than 3. It's equal to 3. In order for this to work, we need a number that is in fact less than 3. So if you were to work on MATLAB, 3 is less than 3, you would get that it is false, or logical 0. The next one, 7 is equal to 7. This one makes sense because 7 is in fact equal to 7. So if you were to type this in MATLAB, 7 is equal to 7, you would get a logical true. 3 is not equal to 8. This one does make sense. 3 is not equal to 8. That means this is kind of tricky because we have not equals to. So does that mean that it's false? Well, you have to look at the expression. You have to ask yourself, is 3 not equal to 8? If that answer is yes, then it will return a logical true. 3 is in fact not equal to 8. So if I were to type that 3 is not equal to 8, we end up with a logical true because this expression I typed out is correct. 3 is not equal to 8. That's a correct statement. So we get logical true. 4 is not equal to 4. This expression is not true because 4 is equal to 4. So if I were to type down 4 is not equal to 4, this expression here is not true. This expression does not make sense. So you end up with a logical false since 4 is equal to 4. Saying 4 is not equal to 4 is an incorrect statement, meaning that you get a logical false. So those are a few examples using relational operators. So next we're going to talk about the logical operators. So logical operators allow for Boolean variables or relational expressions to be connected in such a way to yield another Boolean variable. This means that essentially we can take two different variables or two different expressions and we can combine them in a way to create just one expression. So we can have two different true variables, we can combine them to get another true variable, for example. And it's kind of confusing to explain. It's better just to show by example. So I'm going to start listing the types of operators we can see with this. The first operator is going to be the AND operator. This operator is represented by two ampersands, shift 7. And essentially what you do is you can combine two different logical expressions together using the AND. The best way I can do that is by looking at this example here. So 4 is less than 3 and 2 is equal to 2. The AND is combining these two different relational operators together to make one expression, one logical expression. Now, how does the AND operator work? So the AND operator will return a logical true only if both of the expressions are true. It will return a logical false if either or both of the expressions are false. So let's look here. So we can list two different relational operators and compare them. So the question is asking with the double AND, the AND operator, are both of these expressions true? 4 is greater than 3, that is a true expression. 2 is equal to 2, that is a true expression. This means that the result of this entire thing is going to be logical true, since both of the relational operators give a true variable. Let's type this out in MATLAB. So we have 4, let me clear off a little bit of work here. So we have 4 is greater than 3, and we have 2 is equal to 2. These are two different operators, and we're going to combine them together using the AND. Since both of the expressions are true, the entire expression is a logical true. 4 is greater than 3, and 2 is equal to 2. Verbally using English, it makes sense too. The AND means both of them need to be true for the whole thing to be true. What happens if I were to change it? What if I were to say 4 is less than 3, and 2 is equal to 2? Now I changed one of them. I changed this first one from being greater than to less than. 4 is not less than 3, meaning the first expression is false. meaning that the whole thing will have to be logical false. Since in order for an AND operator to yield true, both expressions need to be true. Since one of the expressions is false, the whole thing will yield a logical 0 or false, because it's not true. Both of them are not true. One of them's false. So that is the AND operator. The OR operator works in a very similar way. It's represented by the double middle bars or middle slash. So this is going to be if you shift and then your forward slash right above the enter button. But so this is going to return a logical true if either or both expressions are true. So this is a little bit different. In the last one, in the AND operator, both of the expressions had to be true. But in this one, only one of them needs to be true. And that makes sense, it's an OR, so either this or that. Only one of the two needs to be true for the whole thing to be true. It returns a logical false if both of the expressions are false. That's the only way we can get false. If both of the expressions listed are false, the whole thing will be false. So let's look at another example here. 6 is less than 8, or 3 is equal to 2. So as you can see here, we have two different expressions. 6 is less than 8, that one is true, and 3 is equal to 2, that one's false. However, since this first expression is true, that means that the whole thing will be true because one of them was true, meaning the whole thing is true. If we type that in MATLAB, let's see, what is it? 6 is less than 8, 6 is less than 8, or 3 is equal to 2. The whole thing will yield a logical true since this first expression was true. The second one was false, but that's okay. Now, however, if we were to change it again, let's say 6 is greater than 8, or 3 is equal to 2. As you can see here, 6 is not less than 8. That's not a true fact. And 3 is not equal to 2. That's not a true fact either. This means that since both are false, the whole thing will be false, a logical 0. So that's how the OR operator works in this case. Both of them, in order to get a false, both would have to be false. In order to get a true, only one of the two actually need to be true. A couple more we want to look at. The next one is the XOR operator. This one's known as the exclusive OR. This one's not as common. You're not going to see this one as much, but it might appear somewhere. So this one must be used as a function compared to the other two. The other two, we put the signs in between them. We've had the ampersands with double bars. But in this one, you use it as a function. So you say XOR, and then you enter two different expressions with a comma in between them, inside parentheses. So this one will yield a logical true only if one of the two expressions is true and one of the two is false. So you're comparing two of them, but it has to be a case where one is true and one is false. If both of them are true, or if both of them are false, then the whole thing will yield a logical false. So look at this example here. XOR 4 is greater than 2, comma, 4 is less than or equal to 4. Both of these relational expressions are true. Since both are true, that means the whole thing yields false, because both of them are true. The only way you can get a true with this is if only one of these two expressions were true and one of the two are false. Let's look at that example in MATLAB. So I use XOR, then I can say 4 is greater than 2, comma, I believe it was 4 is less than or equal to 4. The whole thing yields a logical false. And this is kind of the syntax used. You have XOR, the parentheses, and you separate the two relationships with a comma. So 4 is greater than 2, that's true. 4 is less than or equal to 4, that's true. Since both are true, that means the whole thing will yield false. The only way we can get it is if only one is true. So let's change that. Let's say XOR 4 is greater than 5, comma, 4 is less than or equal to 4. In this case, this expression is false, but this expression is true. So it will yield a logical true. So hopefully that makes sense. It's a little bit tricky. It's not as common. You're not going to see it as much, but there might be a case where you need to use an XOR operator. Last one I'm going to talk about is the NOT operator. So this one is represented by a tilde. It's just a single thing this time by a tilde. And it will return the opposite logical variable that would have been yielded by the expression. So it returns a logical true if the expression following the tilde is false. And it returns a logical false if the expression following the tilde is true. So once again, best to look at it with an example. So tilde, and then in parentheses, 3 is equal to 5. So 3 is not equal to 5, so that would give us a false. But since we have the tilde in front of the whole thing with parentheses, that means we are going to return the opposite of whatever that value would be. So the opposite of 3 is equal to 5, that would yield false, but the opposite is true. So the whole thing will yield a logical true. So I can say that. Let's do that example. So 3 is equal to 5. That yields a logical true. Even though the expression we had was false, the tilde in front of it switched it and it made it true. We can do the same thing if we said tilde 5 is equal to 5. This would give it true, but the tilde makes it false. It gives us a logical 0 because we have the tilde in front of it, which negates whatever we had at the beginning. You can even use this with a logical variable. So right now I have var. See, var is equal to a logical true here. But if I were to say tilde var, the var is true, but since you put the tilde in front of it, that means that that would turn that true into a false. So that is the not operator. Oh dear. Here we go. So now I'm quickly going to talk about the precedence of operators. Basically, what happens if we have multiple operators, relational, logical, mathematical? What if we have them all together? What happens? How do we order them? What comes first? It's kind of like order of operations. And as you'll see here, the relationship or the way we actually evaluate these is very similar to order of operations, but it's a little more advanced. There's a few more things you have to be aware of. So the first thing is parentheses. You do whatever's in parentheses first, just like in a math class with order of operations. Then you have your exponent, very similar again, you do all the exponents. Then next comes the not operator, meaning that if there are any not operators anywhere, you are going to use those. You're going to negate any true or falses that are in there. You're going to do that next. Then the next thing's multiplication and division. Then you do your addition and subtraction. Then you do your relational operators. So once all the multiplication and addition and subtraction and exponents, once all that's done, then you're going to be comparing. You're going to see, okay, let's look at the less thans, let's look at the equal tos, let's look at the inequalities and all that. Then you look at the and operator. So after you do all the relations and all that stuff, you say, okay, where are the and operators? Do I use those? I'm comparing two different relational expressions. How do I compare those? Then you have the or operators. How do I compare these? Are there trues and falses? Am I going to get a true out of this? Am I going to get a false? And the last thing is an assignment. So let's say you're assigning this big long expression to a variable. The last thing you would do is you'd find out whether it's true or false, and then you'd assign it to the variable var or num or whatever you want to call it. So once again, the best way to look at all this is by doing a few examples. So I have a few examples prepped up here. So this is a pretty, there's a lot we have going on here. So we have 3 plus 1 is less than 10, and 108 divided by 9 is less than or equal to 3 times 4. So there's a bit going on here. So we are going to want to simplify this down the best we can. So the first thing we're going to want to do is look at our precedence of operators. So we didn't have any parentheses, we didn't have exponents or knots, but we did have multiplication and division. So that's going to be the first thing we end up doing here. Let's do all the multiplication and division first. So let's see what happens if I do multiplication. So we still have 3 plus 1 is less than 10. And we have division here. 108 divided by 9 is 12, is less than or equal to 3 times 4. 3 times 4 is 12. So this is what we have now. Now if we look at the precedence again, you'll see that the next one is addition and subtraction. And we have one addition that we have to do here. So let's do that. So 3 plus 1 is 4, is less than 10, and 12 is less than or equal to 12. So this looks a little more familiar to something that we're actually going to want to have. This looks like something we can solve. Let's still use the precedence just to be consistent. So the next thing we have is the relations, so the inequalities and all that. So 4 is less than 10. That's going to give us a true, because 4 is in fact less than 10, and 12 is less than or equal to 12. That is also going to be true because of the equal sign. Finally, we're going to use our and operator. It's the last thing we're going to do. So since we have two trues here, that means that the whole thing will be solved as true, because the only way you can get true with the and operator is if both the expressions are true. Since both are true, that means our final answer is true. And then we're done. So that whole thing simplified to being true. And then, in fact, I could copy and paste this in MATLAB if we wanted to actually see the results. I can paste it here. You'll see the whole thing actually results in a logical 1, the true variable. So we know that we did our math correct. Let's look at this one here. So we have negated in quantity, 34 is greater than 21. The or operator, 54 is not equal to 54. So we have a few things to do again. So what's the first thing that we're going to want to do according to our precedence of operators? So the first thing is going to be the parentheses. So we're going to want to do everything inside our parentheses first. If we go back to this example, so we have a couple things in our parentheses here. We have a couple relational operators. So we're going to keep the or, And then what goes in here? 34 is greater than 21. That's going to be true because 34 is greater than 21. And then what's going to go in here? So in here, we end up having 54 is not equal to 54. That's going to be false because that expression is not a correct expression. 54 is equal to 54. So in this parentheses, we're going to have to say false because 54, it is equal to 54. So that means that this expression here is false. So now we have this. The next thing we're going to want to do, according to our precedence, is going to be the not operator. So we do have a single not operator here. And what that does is it negates whatever's inside our parentheses. So we had true, but since we have the not operator, we have to flip that true into a false because of the negation operator, the not operator. So now we have false or false. Now with the or operator, if either one of the expressions is true, then we can say the whole thing's true. But since both of the expressions are false, the only answer we can get from this is false. So that's going to be the answer to this thing here, is going to be false. Let's look at another example here. So this one's got a bit going on with it, but let's see if we can tackle this one. So we have a couple, you know what, the best thing to do is, I'm not even gonna read it. Let's just see what we have to do first. So if we remember what we have to do first on our precedence is we have to look at the parentheses. So we have a couple sets of parentheses. So let's focus on everything inside this first set of parentheses. Let's focus on this stuff first. So looking at this highlighted region, we're gonna say the first thing we're gonna wanna do is the multiplication. So we're going to say not, so we got 5 plus 2 is greater than 7, or, and then we have our multiplication. 6 times 2 is 12 equals 12. So we have that simplified. The next thing we want to do is the addition. So we're going to have not, parentheses, not. 5 plus 2 is going to be 7. 7 is greater than 7, or 12 is equal to 12. Now let's work on the relational operators. Let's do the inequality and the equality. So we still have not. 7 is greater than 7. That is not a correct statement. That means that we're going to get false from that because 7 is 7. It's not greater than 7. So we have false, or then we have 12 equals 12. That is a true expression, so that's going to be true. Now let's work on the or operator. So we have false or true. Remember, with the or operator, only one of the two relations needs to be true. The first one's false, but the second is true, meaning the whole thing simplifies to being true. So we have not true. Now, once again, let's look at the parentheses and work out one at a time because this looks a little weird. We have a couple not operators. We're going to discover something here. So first, let's work on the one on the inside. So we have a negation of the true, not true. That means we have to flip the true to be the opposite. So now we have not, and then inside the parentheses, we have not true. Not true simplifies to be false. Now what we can see here is we're going to reverse that result. So we have false, but we have to negate it, making it true. So as you can see here, the two negation or not operators end up just canceling each other out. And that's something you can do with the not operators, is if you have two of them, they end up just canceling each other out in the end. They're going to cancel each other out in the end. The whole thing simplifies to be true. Here, so we say let x represent an integer variable, write a logical expression to determine if x is greater than 10 but less than 30. Okay, so this seems like it's pretty straightforward. If you're taking a math class before, you might see, okay, it has to be greater than 10, but also has to be less than 30. So we could write 10 is less than x is less than 30. And this seems like it should all work out in the end. Like this should be completely fine. So, you know, let's end up texting that. So we can say x is equal to, I don't know, 15. So we have that. And then we can say, all right, 10 is less than x is less than 30. It ends up giving us a true. It ends up giving us what we want. Awesome. So we're in the clear. It seems like it. But what would happen if x is equal to 45? So this one clearly can't work because 45 is not greater than 10 and less than 30. But if we end up saying that, so 10 is less than x, less than 30, we end up with a logical true again. We ended up with something, so this one was completely fine because it was a logical true. But it shouldn't have worked. It should not have given us a true fact because that doesn't end up working with the two. 45 is greater than 30. So what's our problem here? So the problem was looking at the precedence again. What it ends up doing is only taking into consideration this 10 is less than x. As long as it ends up being less than, if it ends up being greater than 10, it's completely fine. It's not going to have any problems with it. So that's kind of a problem. So we can't use that to write it. This expression won't work in all cases. What we have to do is we have to be very particular about what we want to say. So we want to say it's greater than 10, but less than 30. So that means that x is going to be, I don't want a capital X, so x is going to be greater than 10, but it's also going to be less than 30, means and it's less than 30. So we could say x is greater than 10 and x is less than 30. This is how we're going to want to accomplish that problem here. We can't use the 10 less than x less than 30 method. This is what we're going to want to use in actuality, because this is going to be correct. If I end up copying and pasting this, so now let's see what happens. So x is still 45 right now. So what happens? This time it returns a logical 0 because it sees this part here and says, okay, x is not less than 30, it's 45, meaning that it's going to give us a logical false. So you have to be very particular about how you use this. You need to use OR operators, you need to use the AND operators to get the correct answers in the end. All right, so the last thing I want to talk about before I halt this video is going to be short-circuiting with logical operators. So the AND and OR operators that we talked about, the double ampersand, the double vertical bar, they can utilize something that's known as short-circuiting. And this is just a little tidbit. It's not super important, but you might end up finding it useful. So for the AND operator, MATLAB will proceed to skip checking the second expression if the first expression is already false. So that might be a little confusing at first, but if you actually think about it, it makes sense. So what it's saying is if the first expression using the AND operator is false, MATLAB won't even consider the second expression. Because if one expression is false with the AND operator, the whole thing has to be false. In order for the thing to be true with an AND operator, both expressions need to be true. So look at this one here. It says 3 is less than 2 and 8 is greater than 1. So we know that 3 is not less than 2. So this here is going to be a logical false. Since it's a logical false, there's no point in even checking what this part is. This part is false, so the whole thing has to be false. Because with an AND operator, if either one of them is false, it results to false. So MATLAB won't even check that 8 is greater than 1 since the first relation is already false. Likewise with the OR operator, MATLAB will proceed to skip checking the second expression if the first expression is already true. It's kind of the reverse with the OR operator. If either expression is true in an OR operator, the whole thing has to be true. So look at this. 4 is greater than 2, or 2 is equal to 4. We know for a fact that 4 is greater than 2. That results in true. So there's no point in even checking the second part. We know this is true, so the whole thing has to be true. So we can actually see MATLAB do this in practice. Let's clear our variables. Let's do this. So let's say I have something like this. Let's say I say 10 is greater than 2 or y is less than 3. So this is what's interesting here. This expression, if we didn't use short-circuiting, should turn out as an error because we don't have any, look at our variables here in the workspace, we have no variables. We don't have a y variable defined, so the whole thing should result in an error because we don't have a y variable. How could this possibly run? But if we end up running it, it ends up working completely fine. Answer is logical. And the reason why is because of short-circuiting. MATLAB saw that this expression was true, so it didn't even look at this part here. It didn't even look at anything. Because we knew this was true, so the whole thing has to be true. We can do the same thing if we said 4 is less than 1 and y is equal to 5. The whole thing results in a logical false still, even though we don't have y defined. But let's say we put y in the first one. If we were to say y is greater than 2 and 4 equals 3, then we have an error here. It says undefined function of variable y. That was because MATLAB still had to read this part. In both of these two examples, MATLAB didn't even have to check this part or check this part because it already knew looking at this, oh, 4 is less than 1, the whole thing has to be false. Oh, 10 is greater than 2, the whole thing needs to be true. So you may end up finding yourself in a situation where you can use short-circuiting to prevent some kind of error happening because of the way you set up like the order in which you put your relational expressions. So that was the last thing I want to talk about. Thank you so much for watching, and please subscribe.